Hey there, this is Bruce again, Z Group Energy. For those of you interested in alternative energy, I'd like to talk to you just a little bit today about our Z Group Energy closed geothermal system and how it differs from conventional geothermal systems and why that might be significant. Again, I'm going to have a sip of coffee. It's a great question, by the way. And I will answer the second question first, which is, why is it significant? Well, I guess the primary significance, just in terms of economic sustainability and potential positive return on investment, both of which are necessary components of any proposed energy system, is comparatively lower estimated cost of operation. That's what the ZGE system gives you. Now, we estimate that Z Group Energy's closed geothermal system, utilizing supercritical temperatures to produce electricity, is going to come in at a cost of about 4.5 cents per kilowatt hour. Now, this is truly significant because today's most cost-effective technology would utilize natural gas at a cost of about 7 cents per kilowatt hour. The second most cost-effective alternative energy source today would be conventional geothermal energy, and that comes in at around 8 cents per kilowatt hour. So both of these come in at nearly double the cost of operating the ZGE group system. So this is very significant. Now, the first question, how does our system differ from conventional geothermal? That is going to take just a little bit more effort. I guess the shortest possible answer, if you will, simply addressing the environmental concerns or byproduct emissions, if you will, is that the ZGE closed system has a byproduct emission of H2O, water, nothing more, and our system does not require any fracking ever. Okay? Now, natural gas, for instance, fossil fuel, is not renewable. It frequently requires at least some fracking, and as a power-producing fuel, it does emit CO2 and other byproducts. Now, conventional geothermal is renewable if the geothermal reservoir isn't depleted by extracting the heated in situ brines at rates exceeding the reservoir capacity to replenish itself. However, the direct use of these in situ brines, which conventionally is done, tends to bring contaminants such as boron, arsenic, hydrogen sulfide, etc., out of solution. And when you're heating and cooling, these chemicals and minerals come out of solution, and that requires treatment both before and after use, and that's a problem that the ZGE system eliminates. By Sonara, it's gone. Now, as a side note, conventional geothermal plants do sometimes use fracking to improve the rock strata permeability, which boosts electricity production. I'm not sure how big of a problem this is. It's not proven, but some people are concerned about it. And at any rate, ZGE does not use fracking, only drilling. Now, a more detailed answer regarding the differences between ZGE's closed system and conventional open geothermal systems is as follows. Conventional geothermal systems extract, as you probably know, Earth's thermal energy by heat mining hot underground fluids via a return well. These fluids carry heat energy, and that heated fluid can be used as fluid or steam, usually steam, to run a steam turbine, generally via some variation of the Rankine cycle, converting heat energy to mechanical energy and finally to electrical energy. So basically, the spinning turbine runs a generator converting mechanical energy into electrical energy for delivery to a distribution grid for use by industry, by residential customers, whoever. Now, in many cases, the underground fluids, sometimes called brines due to their high mineral or chemical content, are re-injected back into the below-ground reservoirs to replenish the reservoirs via an injection well. This has to be done for reservoir recharge, if you will. And this re-injected fluid is then heated, harvested via the return well, and the process continues. Now, conventional geothermal technology utilizes what I call, anyway, a two-pipe, two-well approach with return wells for harvesting and injection wells for below-ground reservoir recharge. Now, this requires additional expense and also the unappealing aesthetics, I suppose, and maintenance of additional associated piping, valves, and appurtenances necessary for a two-pipe, two-well type of system to be functional. Now, a common conventional geothermal issue is depletion of the below-ground reservoir levels. Now, if the in situ brines, that's the in-place brines that conventional geothermal makes use of, if those brines bring chemical contaminants out of solution via the heating and cooling cycle, those brines have to be treated before being re-injected back into the reservoir. In the United States, the EPA requires that it be treated. You can't put these chemicals that came out of solution back under the ground. The corrosive, sometimes toxic character of these brines can damage sensitive power plant equipment if it isn't treated. If these treated brines are not re-injected underground, as is sometimes the case, and they're discharged to, say, a watercourse, a lake or stream, then additionally, those brines have to be cooled or the receiving ecosystem may be thermally damaged. Now, by contrast to all that conventional situation, the closed ZGE system uses the same heating cylinders, or well, for convectively heating and reheating, thereby eliminating any need for re-injection wells and the associated costs and poor aesthetics related to the extra piping, connections, valving, and etc. If you go look at conventional geothermal systems, you'll notice that there's above ground pipes running all over the place. You will not see that with a ZGE closed system. The ZGE heating cylinders, the wells, are completely closed. They're sealed. So they contain only the clean fluid internally provided from within the system itself. Now, this is contrary to conventional geothermal technology, where all the return wells have open perforated bottom sections so that they can intake the in-place or in situ hot geothermal brines, which, as mentioned, can be corrosive or even toxic. Now, conversely, before I get into that, conversely, the injection wells are also open and perforated on the bottom because we have to re-inject fluid back into the reservoir to replenish it. So again, we need a perforated bottom. So these conventional open wells invite logistical environmental hazards, and they also increase operating expenses that the ZGE closed system avoids. Now, the ZGE system heats its own internal fluid, for today's purposes, let's assume water, via thermal conduction from adjacent below-ground hot rock, and then internal non-partition convection and heat transfer. Now, this eliminates concerns regarding the permeability of underground rock strata, as no fluid is ever required to flow through the rock. Any need to increase rock strata permeability via high-pressure fluid injection or what they call fracking is eliminated. We don't do that with our system. Now, our convective flow regimes will establish themselves within the ZGE heating cylinders or wells, and the exchange chamber pending design considerations utilizing critical or subcritical flows, system pressures, etc. Those things will vary, but the convection will still be going on. The ZGE non-partition flow regime, while reducing the individual harvesting capacity of each individual well somewhat, as inflow and outflow are occurring convectively and simultaneously, it also eliminates all of the double piping and injection wells required conventionally, resulting in an overall net reduction in cost without any sacrifice in electrical production capacity. Now, the closed ZGE system can use pure water, as we said. Therefore, it never exposes any equipment or the environment to potentially toxic or potentially corrosive underground brines, as the conventional technology does today. Now, I want to mention here that the ZGE system is not limited to water, okay? That's the most likely fluid that we would use. But we don't have to use water as the heat carrier. And since it is a closed system, any fluid at all that possesses high heat carrying capacity can be utilized with virtually no danger of pollution as long as the structural integrity of the system remains intact and it isn't leaking. Now, in any event, cooling is not an issue with our ZGE closed system either, because other than planned system bleed off, slight accidental leakage, and evaporative losses that are going to occur, the fluid is reused in a continuous heating, cooling, heating cycle. So after the startup procedures are complete and all the containers and the tanks and the pipes have been filled initially, the replacement operating water demand of the ZGE system is far less than that needed for conventional open geothermal systems, and that of course reduces the operating cost. Now, electricity production, if you don't know this, typically requires vast amounts of water. That water is heated in a boiler, and then it's flashed to steam, powering a steam turbine, the generators, etc. Now, this water demand can be as high as 3 tons per single megawatt hour of energy output. Therefore, a cost-effective fluid source is necessary to maintain the system. It's absolutely critical. Now, the ZGE system drastically reduces the cost of meeting this fluid demand because, again, after initial startup of the system, the only water displacement demand results from planned system bleed-off, evaporative losses, and some small amount of leakage if there's some leaks in the system. Now, at the Geysers Geothermal Plant in Northern California, for example, the ZGE system would very likely eliminate the need and operational expense of operating the costly Southeast Geysers effluent pipeline that is currently employed to recharge the geysers below ground reservoirs in order to sustain economically feasible electricity production. Now, just to summarize, the Z Group Energy closed geothermal system differs from conventional geothermal technology, and the ZGE system is significant in today's market for the following 10 reasons. All right, and I'm just going to go over these very quickly. 1, the ZGE system is closed, thereby reducing environmental impacts. 2, after startup, operational water demand is comparatively small. 3, all emissions other than H2O, water, are eliminated. 4, toxic, corrosive aspects of in situ brines, in place geothermal reservoir blinds, eliminated. 5, treatment of in situ brines, eliminated. 6, cooling in situ geothermal brines, if you're going to discharge it to a water course and waste it, is eliminated. 7, reinjection wells and extraneous piping and appurtenances necessary for the 2-pipe 2-well system, eliminated. 8, fracking is eliminated. 9, The ZGE system, utilizing supercritical temperatures, which is how we envision it most cost effectively being used, appears to be the most cost effective method proposed by anyone for the production of electricity. Now, if you want to see a cost comparison, go take a look at the Z Group Energy homepage, and there's a link there to what we call the Energy Technology LCOE, that's a levelized cost of energy, comparison worksheet, and that shows the operating costs for most major energy production technologies today, and you can see how those are ranked. It's pretty good information, and it'll give you a quick overview of where we stand in these rankings and why we think we are significant with our technology. 10. If, in the event, supercritical temperatures were not employed, I'm not sure why a system operator would want to do that, but if for some reason supercritical temperatures are not employed and cooler temperatures are going to be used, the ZGE closed system will still remain cost effective with any geothermal technology and with most other technologies, particularly natural gas, our biggest competitor cost-wise, but ZGE provides the additional benefit of eliminating all environmental emissions totally except water. Now, I hope that my little comparison here has helped you to understand our Z Group Energy system a little bit better and why it is significant in today's energy market. If you have questions, please feel free to contact me. My name is Bruce, and you can reach me at my email, bruce@zenergy.com, or you can comment on any page of our website. You can comment on our Facebook page, and you can also comment on our Z Energy YouTube channel. Now, thank you so much for taking the time to listen to my little comparison today. I hope that you found it helpful. And we'll be posting future vlogs and trying to share other information for you. So come on back and see us. Thank you so much.